Good afternoon everyone, and welcome to today's webinar, How to Test and Deliver Resilient, Functional and Secure APIs. Before we get started, I'd like to go over a few items so you know how to participate in today's webinar. You'll have the opportunity to submit text questions to today's presenters by typing them into the questions pane of the control panel. The control panel is situated on the right-hand side of your screen. You can send these questions in at any time during the presentation. We will collect your questions and address these during the Q&A session at the end of the presentation. Today's webinar will last for approximately 45 minutes, with 15 minutes at the end for your questions. Following the webinar, you will receive the recording of today's presentation and a short survey, which we would greatly appreciate you completing. We welcome your comments and suggestions, the results of which will assist us greatly in bringing you more of what you would like to see. I would now like to introduce you to our presenters, Harsh Apriti from SmartBear Software and Daniel Geeta from Qualitest Group. So over to you, Harsh and Daniel.
Thanks, Sarah. Hello, everybody. Good morning, good afternoon, good evening, depending on wherever you are in the world right now. So today's agenda is going to include a lot of things. We're going to talk about APIs and APIs testing primarily. We're going to step through this whole process by starting with the evolution of APIs. How did the APIs came into being and where they are right now? We will see the right way of testing APIs. We will take a look at the concept of testing environments and especially API environments. And then we will go ahead and talk about some patterns around API testing in DevOps. And as Sarah said, towards the end we would have some time for you to ask us questions and for us to answer your questions. So let's dive in. So how did APIs come to the stage they are in right now? We hear about APIs a lot these days. APIs economy is expected to be around $2 billion in the next few years. It all started at around 1998 at Microsoft, when some really brilliant engineers thought that the internet and the web could be used not just to serve static pages, but also services in the form of some computation and logic and data. So they came up with the concept of XML RPC. It stands for XML over remote procedural calls. So in the first box on the left, you can see a typical request for an XML RPC. So what you see here is that a lot of information has to be carried in the payload. The method that is essentially the computation that is to be done on the server side has to be transmitted first of all. The data, that is in this case the stock ID of IBM, has to be transmitted as well. It was a good solution. But what happened was, as people developed these APIs more and more, they had to go in and meet the other teams frequently because there was no standard definition of these APIs. It was difficult for machines to automatically read the specification and the methods. So it was a big problem. So as this problem grew, people thought that we should solve this, and the concept of SOAP came into being. SOAP was very much driven by specification that was called WSDL, the Web Services Description Language. So what engineers did was that they used to write this code, and then they would generate this definition out of this code. And this definition would then be given to other teams for them to incorporate in their software and systems as API calls. It was a very good system. But the problem was that it was very much complicated. It had a lot of functionality, it had a lot of standard to it, but at the end of the day it was only machine readable. It was complicated, not comprehensible to humans, and discovery was only possible by machines. So eventually engineers thought that we should simplify this even further. And then there was this whole architectural shift from just web applications to more mobile applications, where people expected these APIs to be very much lightweight. So standards like SOAP with their heavy payloads, with the envelope, the headers, didn't fly much in the light of these kind of requirements. So again, people thought that we should simplify this even further. So the concept of REST came into being. So REST stands for Representative State Transfer. And what REST does is it uses the inherent HTTP methods, that is the GET, POST, and then uses it to transfer payload from the client to the server. it's brilliant because it uses what already exists in HTTP and then builds on top of it. So if you can see in the third box from the left, you would see the get request for a stock price, and this request makes a lot of sense. You say get a stock price and I give you the stock name in a very light payload. So this configuration works very well with today's applications which need lightweight transmission of data between client and server. As the REST evolved, there was a need for a lot of standardization around REST because everybody had their own implementation, their own interpretation of REST protocols. So the concept of Swagger came into being. So what Swagger does is it provides you the ability to do design-first development of APIs. So what do we mean by that? I talked about SOAP earlier, in which I said that code needs to be written by engineers and then you generate the specification. But then that is not the right way of doing things. The way you do software development these days is you have to do the design first. You have to put a lot of effort and thought in the design of the APIs and then you generate the code. Swagger enables you to do that. It enables you to design an API in a very text-based format, in a very human-readable format, and then you can use that standard to generate the code. So this is where we are right now. It started in 2010. And it's a very popular protocol. I highly recommend, if you have not heard of it, that you should go ahead and explore Swagger definitions. And what's in store for APIs in the future? Well, I think Swagger is going on really well these days. What we hear from our customers is that they're starting to move from SOAP to Swagger right now. But people in Swagger land, in API land, are already thinking about the future. So Swagger 2.0 version is now called OpenAPI. It's a standard that is built on top of Swagger. It's even better and much more human friendly. We are also seeing a lot of traction in the IoT space. And IoT space includes protocols like MQTT and CoAP. And there is a lot of different communication paradigms on IoT as well. So let's talk a little bit about communication on APIs. So there are basically two types of ways in which APIs communicate. One is asynchronous and the other one is synchronous. So what does it mean? So by synchronous, what we mean is that APIs communicating between a client and a server communicate in pairs. So you send a request from the client and the server responds with some information or data. You have to keep in mind that in synchronous communication, request is always needed before you get a response back. HTTP protocol is inherently built for synchronous communication because when it came into being, it was that you would type in a URL in the browser and you would get in response a web page. So it's a typical example of request-response pairs. We talked about REST and Swagger before. So REST and Swagger supports get and post. Get to get information from the server and post to post data from the client to the server. So what is asynchronous? So building on the context of synchronous, asynchronous means that server can send information to client even without any prodding from the client. So we do not need a request from the client. Information can flow from the server as soon as there is information available there. Think about Facebook. If you would have been on Facebook maybe 10 years back, if a friend liked your update, then you would have been able to see it only once you refresh the browser. But now what happens is that as soon as your friends like your updates on Facebook, you get to see the information up front. So that is an example of asynchronous. Well, in Facebook, what they have done is they have built on top of HTTP this asynchronous mechanism, but then there are other technologies which are available in asynchronous. So JMS, the messaging, Java messaging service is an example where you would have asynchronous communication. A server can update all the peers or clients as soon as they have information. WebSockets is a very good example. So it's built on top of HTTP. It lets a stream of data flow from the server to the client. So you can do things like screen sharing on web applications. So it's a form of an API, but very much asynchronous and advanced. So what's happening these days is that internet is really becoming very much asynchronous. So you have to think outside the box of web applications. We are seeing really responsive web applications. We are seeing applications like YouTube on which we do so much of streaming of data. We are able to make video calls and voice calls on the internet and on web applications. All of this is happening through APIs. And as I talked about IoT, well, the devices in IoT which have sensors would get this data, and then they will transmit the data back to an IoT hub, and that hub would asynchronously transfer the data to a cloud server for data analysis. We have talked about different APIs, standards. We have talked about the mechanisms in which these works. But let's talk about how typically APIs are consumed these days. So traditionally, we have seen that APIs had to be installed by our customers on-premise. What that meant was that data and information lives on a server in a data center that is controlled by the customers. So it's all on-premise. And an application of the customer would hit this on-premise data through an interface. So it brings a lot of problems to the front. Number one thing is that you have to do all of the overhead infrastructure management yourself. You have to buy the servers, you have to buy the staff to manage those servers, you have to manage the security using some middleware. You have to ensure reliability, that if the information comes in from an application on the left, that is in this case on the slide an e-commerce application, that information gets passed to the CRM through the APIs correctly. So you have to build this whole middleware, you have to build the data center, you have to build the staffing requirements. So that's a lot of capital expenditure. And also there are very high operational costs. A good thing is that because security and reliability is in your control, and if you are able to invest right in those areas of staffing and infrastructure and the right solutions, you can assure yourself that you will have a really robust solution. But you have to do a lot of infrastructure management yourself. It also means that you have to create your own SLAs and manage them yourself. On the contrary, the other paradigm that we are seeing come up really fast on API delivery is on cloud and SaaS. So on the diagram in the below section of the slide, you will see the e-commerce application is hitting the CRM application over the cloud. So what happens here is that the whole layer of security and reliability has now moved inside the cloud, which is being given to you by a service provider. It could be Amazon AWS, AWS Lambda, or it could be out-of-the-box service provider like Salesforce. So what are the benefits of this model? The benefits are that this is very low cost. Well, upfront there is no capital expenditure. Your operational costs are just limited to pay as you go for the APIs. It's all off-premise, so you do not have to worry about having a data center, supplying consistent power to the data center, having fire extinguishers available there if in case there is an incident. So there is no infrastructure costs available. But the only thing is that instead of SLA management, you are now doing SLA monitoring. That is, you are investing in tools and people who are looking at dashboards to figure out that APIs on your applications are being consumed well. All right. So with that, let's move on to our next section, and Dan will take you through the right way of testing APIs.
Okay, thanks very much, Harsh. So when we talk about testing APIs, there's two types of APIs that we need to consider. There's the APIs that we are building, and there's the APIs that have come from third parties. We'll move on to the third parties in a minute. But let's talk, first of all, a little bit about the APIs that you yourself are in control of. Well, naturally, your APIs are a service offering. You need to make sure that functionally they do everything that any of your other service offerings do. You need to know that people know how to use them, that the messages are clearly defined and easy to understand. You need to ensure that when your API is given the correct information, you handle the correct responses, you give the correct replies to your users. You need to check that if your API has got multiple related calls, they all work together. You basically need to check sort of the sanity of your API. When we're testing our own APIs for their functionality, we can use all of those testing methods that have always had a good and successful history with standard functional automation testing. So for instance, we can test various combinations of data to drive all the functionality of our APIs. We can check 1,000 different types of API call to make sure that whatever data our customers throw at us, our APIs handle it correctly. We can check the discoverability of the APIs, the fact that if we're still using something like a WSDL-defined API, the WSDL is still valid. We can offer the right information to our users. But API use is exploding. More and more people are developing loosely coupled and microservices-based architectures whereby you're exposing your APIs to the outside world. It's no longer a case of a particular middleware component might use your API, and you can work quite closely with the development team if they don't quite understand what's going on. We're now at the point where lots and lots of people are using APIs that they don't necessarily, and you don't necessarily have control over who those people are going to be. To do that, we need to know that your APIs are secure. We need to look beyond the functional testing. We need to make sure that your APIs handle malicious inputs, or maybe they just handle bad inputs, whether or not there is a malicious intent behind them. You need to make sure, if you've got APIs that can handle confidential data, firstly, that only the correctly authenticated users can see that information, and that they can only see information they're allowed to see. Imagine things like APIs for payment details, or to go back to Harsh's example, CRMs. You need to make sure that when people are connecting to APIs, they can only see the details of accounts that relate to them. A lot of the concepts of session stability and session security that we've seen in standard HTTP web browsing patterns apply to APIs. At the end of the day, APIs are still built on a lot of the HTTP technology stack. So all those things to deal with session integrity, session concurrency, still need to be checked and locked down on your APIs. We also need to make sure that our APIs are encrypted. Providing API access via SSL and TLS is important to make sure that you don't get snooping on API traffic. Beyond securing our APIs, we also need to ensure that actually our APIs perform right. If you think of someone like Google Maps, where they have millions and millions of requests a day coming into their APIs, you need to ensure that your API can scale to meet that demand. Imagine the outcry if Google Maps went down one day. Every single one of those connected services on your phone that uses the Maps API would also cease working. So we need to ensure the scalability and the availability of our APIs. We need to make sure that when we're given a request, even in an asynchronous communication model, we still respond in a reasonable amount of time so that our users don't lose interest in whatever information it is we're providing or seek an alternative source. We also need to be able to handle concurrency of responses. If 10,000 users request something, you need to make sure you can reply to 10,000. And if we do start to approach bottlenecks in our infrastructure or in our performance, we also need to make sure that our API handles those well, that you don't just suddenly see your API drop off the map. You need to ensure that if, for instance, resources are being stressed, you need to make sure that you can send informative error messages and helpful diagnoses back to your users. All of these things we've been doing for years with our applications, whether they're web applications, desktop applications. APIs are exploding onto the scene, and we need to make sure that we understand that they are every bit a unique interface into our applications, as a website was traditionally in the past, or as a desktop is. We need to focus on testing all of these too. That's pretty straightforward. I mean, testing your own APIs, you have full control. But what about when we're testing third parties' APIs and our integration and consumption of their data? In a lot of cases, you may be fully dependent on somebody else's information. Let's say you're writing a plugin for something like a CRM system. You need to make sure that CRM is always giving you valid data. If you're writing an integration layer, you need to make sure that you can handle the information coming from other streams. But you also need to make sure you subscribe to them correctly. If you're connecting to something like a paid API service where every time you write a request, a charge is being made against you, you need to make sure that you get all of those requests absolutely right. What's going to happen to our application if somebody else's API breaks or if it goes down? Their availability might not be tested as well as mine. Or even worse, what if they perform substantial upgrades on their API exposed capabilities, but they didn't preserve the backward compatibility? All of these things are very real concerns for people that are subscribing to another API. So we need to test them. But the problem is, it's somebody else's API. You can't test all of these things yourself. You can't have exhaustive checking like you can of your own APIs. So we need to start thinking about what our options are. Could we use our testing against the real API? It's possible. But a lot of APIs charge by the use. If you're thinking of something like a continuous integration build where you run all of your testing all the time, you can very quickly drive up a huge cost if you're actually using a real API. What about data contamination? In many cases, you do not want, well, in almost every case, you do not want test data and live data ever mingling. And what about destructive testing? If we are trying to see if our application can deal with something like high load, and for every one of our tests we make an API call, well, that means then we're also indirectly exposing a load test to the third-party API. All of these things mean using the real API isn't really viable or advised. Okay, well, what about a pre-production or a sandbox mirror? These tend to be quite good if you can get them. If a vendor has provided you with a fully functional, compatible pre-production or sandboxed API, it should be in complete parity with their actual live API, and you can do all the testing you want to against that. Most vendors don't provide these. It's an additional maintenance overhead on them. If they do, there's probably also another cost associated with it. But even with that, that would be a third-party API in its own right. It's on their pre-prod environment, it's on their demo environment. You still can't force all of the test scenarios. You can't necessarily force that API to throw you an error message. So what's left to us? Well, the obvious one is we build up implementations of the API fully under our own control. There's two main approaches we can use to do this. There's mocking and there's virtualization. Brief description of the differences between the two. So when we talk about mocking an API call, we're not usually making an API call outside of a mock. We are talking within a test. We've said, in this test method, I'm going to make a call to this thing. It's not ever actually going to go through the IP stack and off the box. I'm just going to pretend it did, and I'm going to send this response back. So in my test, when this piece of functionality is called, which would usually go off and request something of an API, pretend you got a valid response and return this piece of JSON or this snippet of XML. These are very, very lightweight test fixtures. They tend to be used in very specific situations, often at the unit level of testing. You're looking for a specific method response to pretend it came from a live environment to see if your application behaves correctly with it. You don't need any specific hosting for these. You don't need any specific infrastructure for these. They're just set up in traditional unit test terms. You can think of them as another part of the before test. This also means there is very limited scope for reuse on a mocked API call. You can copy-paste different bits of mocking stuff between your tests, but generally each one is set up and lives entirely within the test method lifecycle. What about virtualized APIs? Well, what do we mean by that? What we're talking about with a virtualized API is we're saying we're going to re-implement the API. We're not just going to say within this test, pretend you're calling out to a real API. We're actually going to put an API on a server somewhere that we can talk to. One of the massive advantages of APIs being defined by contracts, whether it's WSDL definition or whether it's something like a Swagger API, is the exposed points of that API are discoverable and then known. And what that means is we can say these are all the possible paths, and this, to a greater or lesser degree, is what I would expect the responses to look like. So I can build a test API for myself. All I need to know is the contract that that API should obey, in much the same way that in internal services in your application, you might provide a faked service implementation for a test. We're doing the same thing with the APIs. We can provide full and partial implementations. We can turn around and say, look, you are going to expose this method. And when a payload comes in looking like this, whether it's valid data, invalid data, you need to respond this way. It doesn't need to go off and talk to actual real third-party services in the background. It just needs to provide a valid response to my subscribing system. And you can have full control over that. It could be told to respond with data. It could be told to throw an error. You could say, respond, but don't do it in a timely fashion. These start to exist as full pieces of test harness. They do live on API servers that are available in your test environment. That means you can fully share them. They're reusable by all of your users in all of your teams, but you still don't run the risk of contaminating test and live data. Okay, on to the next slide. So that's a little bit about the difference between mocking and virtualization. I'm going to let Harsh take back over now, and he's going to talk a bit more about the different test environments and where mocks versus virtuals come into play.
Sure. At this point, I think it's also a good idea to go in and look at the tool Ready API, which can help you do whatever Dan talked about in the right way. So we're just going to dive in and do a little bit of overview of Ready API and see how it can help you in doing proper functional testing, performance testing, security testing, and also we'll talk about how you can create the virtual services that Dan talked about. So on the screen, you can see Ready API 1.9. It's a tool from SmartBear, and it is an integrated suite of applications to do testing on APIs. So on the top right side, you can see we have SOAP UI NG. This is for functional testing. We have Load UI NG Pro for performance testing, Secure Pro for security testing, and Service vTool for creating virtual services out of your APIs. So we'll go through these one by one. But before that, I would like to tell you that APIs, if you're working with APIs, then you don't just need to test them, but you also have to have integrations with tools and applications that work with APIs. So for example, this tool integrates with a lot of API management systems. So if you are working on APIs on IBM API management platform, or you're working with Amazon API gateways, you can use the integrations of this tool to communicate, to pull those APIs, test them, and then push them back. You also, with any API testing tool, you should have integrations with the bug management and monitoring. So we provide you those integrations to GitHub to pull your code, and with Jira to create bugs in case your test cases fail. All right, so I think it makes sense. Dan said earlier that functional testing of APIs is really important. So we'll just go ahead and look at some API tests that we have created here. So I talked earlier about SOAP and REST test cases. So on the left side in the menu, you can see a test scenario that we have created that includes login, doing a search, doing a buy, and then log out. I'll just go ahead and quickly run this for you. So what happened here is that we right now tested a full scenario starting from login to logout, and we did some operations. And the tool allows you to chain data from login to search, pass parameters from search to buy, and then buy to logout. So this enables creation of these sophisticated scenarios, which could be enhanced with the help of Groovy scripts if you want to. So Dan also mentioned data-driven testing. So it's important for you to ensure that you just do not use static test cases, but also you're able to link your tests to some data. So the tool allows you to incorporate data and properties. So you can pull data from an Excel sheet or from a database into this tool. All right, so after functional testing, what you can do is the best way to move your scenarios to other things like load testing and security testing is to create load tests right from the tool here. So Ready API allows you to create a load test directly from your existing test case scenarios. So why is this useful? It's useful because what you're doing is that you are spending time only once creating your testing scenarios, and then you're bringing those testing scenarios into your load testing tool and security testing tool immediately without any more additional effort. So you can do that very easily through this tool. And so instead of creating your functional test cases and spending time on that and then going in and creating load tests, you seamlessly move from your functional tests to load tests to security tests and also to mocks. So we'll see what happens when we take this scenario of login logout. In this case, I'll show you a REST test case scenario that we have bought in from functional test case that we had built in here. So this is the REST scenario. You log in, you do some script operations, you do a search, buy, and log out on REST APIs, and we are able to seamlessly transfer it into a load testing scenario. I'll quickly run a 10-second load test on this so that you can see the results. So as the load test is running, you can see the graphs populating in the backend. So the tool gives you a great insight on what's happening with your APIs. And remember that this is running the whole testing scenarios. So depending on your requirements, you may want to test the whole scenario, or you may just want to go and test individual operation, that is login or logout. You get really good insights through the tool, through these graphs. You can select different metrics like maximum response time, minimum response time, average response time. The number of failures are in the red, so you will see that it is a spike of failures towards the end of the test run that was run for 10 seconds. So you can do test all those scenarios here. So what it also allows you to do is it allows you to run these tests not just from your local computer, but you can distribute these tests across the world on cloud. So you can add some remote agents through this option of adding cloud agents. So here the screen lets you add an Amazon EC2 instance as a cloud agent that will push load on your APIs. All right. A quick overview of our security testing features in the Ready API tool. So you can seamlessly take your existing test case and bring it to security testing. So the tool allows you to do top 10 OWASP security scans. So if you Google OWASP, these are the recommended scans by an agency that recommends best practices on the security front for owners of APIs to commit to. So you can, with this tool, you can quickly run these scans on your APIs as well. And once you have tested your APIs on security, well, as Dan said, it's important for you to ensure that the third-party services that you're hitting, APIs that you're hitting, are also available. So the tools allows you to do that with the help of Service vPro. So here you can see that there are 2 virtual services that we have created, like the buy request has been virtualized here, and for each buy request we have multiple responses that we have configured. So what you can do is you can actually go into each response and you can control this information. You can link this information to data. So all these responses and these virtual APIs are now in your full control. Other great feature that we have here is that you can share these services onto remote servers. So for example, on the below screen here you can see AWS East is a Word server that is running on my EC2 instance on US East Coast. So my existing service out here is a REST virtualized service that I have created. I can easily take this and I can install it on my EC2 server. So now anybody across the world can access my virtual service. So it enables me to create these sophisticated virtual services, which are like mocks and steroids, and then it allows me to host them on any server around the world. So you can share your virtual services easily with your users. All right, so this is an overview of the tool, and it kind of brings together the best practices that we talked about in our slides with some actual implementation that you just saw. So now let's go back and go to the next section of our presentation, where we're going to talk about testing environments. So what are testing environments? So environments are setups that you and your teams create to ensure consistent testing processes every time. So if you're testing in software, there are basically 2 types of environments that you would be concerned about. One is the environment for UI testing, that is front-end testing. Other one is the environment for your API testing. What do I mean by environments for UI testing? Well, when you are testing an application that has a front end, you and your testers have to create environments, test environments for different browsers, different operating systems. So you can do that either on your own computer. You can spin up virtual machines on cloud. You can have 5 different VMs on AWS. On each VM you can have 5 different browsers installed and you can test them one by one. Third option is to have a complete device lab. That is, like, you will have hardware set up for each and every mobile phone, browser, desktop. A very hard thing to do. On the API side, you will also do some environment management. And as Dan said, that the best way to cater to API environments which are not in your control are, you can do it through sandboxes, mocking, or production. And we talked about what is not right with all these environments. Sandboxes could be costly, could not represent the actual environment in completion. Mocks, as Dan talked about earlier, are really hard to create. They require a lot of manual work. And production, you can actually break production if you're testing it. Imagine doing a load test on a production third-party API. You will end up testing the third-party API more than you would be testing your own software. So it's not a good idea. So API virtualization we looked at the demo of Service V in the tool, and I just wanted to bring the context of API environments and API virtualization together on this slide. So API virtualization enables you to quickly set up APIs. So these APIs could be third-party. It could be APIs that are being created by a team that sits across the office, but they have not yet finished their work. So you can do that very easily on the tool by just recording them and then playing them back. API virtualization also enables you to create some real-life scenarios. As we saw, that you can link data to your responses, and you can run those responses in any sequence that you want. It also allows you to do a lot of edge case replication. What do I mean by that? Like, for example, error conditions. So 500 server error is something that is very hard to replicate because it might not happen frequently on the production environment or on your mocks. But with API virtualization, you can create that with just a few clicks. Sharing of virtual services is very critical, as we saw, that you can actually take a virtual service and you can share it with anybody across the world. So you're not just limited to your own office. You can take those third-party APIs that you have virtualized, and then you can share them anywhere. And also network conditions could be simulated. So in the tool, what you can do is you can actually control the bandwidth. You can say that, oh, I want to replicate a scenario that is at a very low bandwidth because I'm trying to test for a situation when my customers are using their mobile phones on expressway or a highway where they do not have good connectivity. So you can do all of those things with an API virtualization solution. So what does this help you do? Well, number one, it reduces your time to market because your testers are not waiting on third-party APIs anymore. This also results in a lot of cost savings because your testing and delivery cycles are shorter, and you get better products to the market, and you do not spend time waiting for third-party APIs. And it also gives you full control. So we saw that from the UI, you have very quick and easy control on the responses. So you can quickly change responses, and you do not have to do that kind of manual configuration that's required maybe on mocks or on sandboxes. All right, so I think Dan would now give you an overview of DevOps and API testing.
Yeah, thanks, Harsh. So, sorry, we've just got one more slide, guys, I promise, and then we'll let you get some of your questions. So this is the familiar DevOps cycle model that I'm sure you've all seen before, where we go from plan, code, build, test, release, deploy, operate, and monitor. API testing fits in, and virtualized API testing fits in very, very well on the right half of this model. And by bringing in the API testing and the CI and the CD parts of our pipeline, we can really help our DevOps move. So we start with the planning phase. In the planning phase, we've got our API specifications. As Harsh said, maybe your team is working on an API over there that you haven't got hold of yet, but you know what the contract's going to look like. Maybe you're on a third-party API where you can get their specification just by hitting a discovery URL. From the specification, we start to define how we're going to work with the API. From the API specification, we can work out how our mocks are going to look in our code level and our implementations. So we can start to, if we're looking at a third-party virtualized API, we can start to look at our code implementation of the mocking framework. What are the responses going to start to look like when we hit the specified API calls? How do we handle that in things like our unit level build, where if we're trying to do a very, very fast build on something like a CI server, we don't want to have to worry about calling out to a real virt server every time, but we do still want to know that our API calls are working the right way. When we've gone through our mock implementations, then we can start to think about the bigger integrated picture. I'm no longer worried about one specific method. I want to know what the actual behavior looks like when I start to integrate the real calls out to the API. So this is the part where we start to look at, what about a virtual implementation? What about an integration test against a fully fledged virtual API or a sandbox API sitting somewhere else in my infrastructure? What you're starting to see here is we've got the pattern whereby we've gone all the way down the code build and test cycle. We've never once had to reach out to the real third-party systems. We've worked with our mocks, we've worked with our virtual implementation, sandbox if you're lucky enough to have one on your vendor, but for the most part, we haven't had to touch anything that is outside of our control or otherwise volatile. we can have a very high level of confidence that by the time we get to the release stage and we're looking at a real API integration, all we need to worry about is the performance and the security testing. If it's an API you host, you can have brought that security testing one stage forwards. If it's your own API, you can do all of that security testing higher up. You can do that in the virtual implementation stage. But by the time you release stage, you're usually running on pre-prod environments. That's the point at which you need to do the performance and be sure of the security before you go live. All of our techniques for bringing the virtual API, for bringing the API testing left using this virtualization of mocks means we're not waiting until we're in deploy and operate phases to know that our API integration is good. If we've done that, we are one step closer to that seamless unified release pipeline that DevOps is all about. Okay, I think that's about it for slides. Let's see if we've got any questions, guys. So we've got one here, which I think would be best picked up by you, Harsh. Here we've seen AWS integration. Will AWS use be charged separately for use in security performance testing, or is it included in the Pro version?
So the Pro version gives you a way to connect to the AWS integration for virtualization and for your load agents. But yes, when you install the load agent on AWS and the virtual agent on the AWS, you are running the AWS compute engine. So yes, you have to pay for that separately. So it's not included in the tool. But the tool enables you to connect to that. And there's a very innovative feature in the tool that allows you to look at the potential billing of how much you're going to charge if you're going to run a particular test. But yes, to answer your question, the AWS billing is separate from the tool.
Okay, so we got another one here. Did we watch a demonstration of SOAP UI or Ready API? You saw a demonstration of Ready API, which is all of the SOAP testing plus the performance testing and the security testing functionality bundled into one nice product suite. I think is the best way to describe that.
Yes. So yeah. So Ready API, as I said in the beginning, it's a set of applications that allow you to do comprehensive API testing and API virtualization. So yeah, so the job to be done that you would do with the tool is functional testing, security testing, load testing, and API virtualization. But we put it together in a very nice bundle for you so that you can easily create your functional test cases and convert them easily to load tests and security tests.
And I believe you also offer those independently as well, don't you, Harsh? So if someone's already got a load testing solution in place, but they want a security testing solution, they're able to do that, aren't they, I believe?
Yes, so they are licensed independently and separately. So typically people use our SOAP UI open source solution, and then if they want to do more, they will buy our SOAP UI Pro solution, and then they will move on to a load testing solution. And at each step, they can buy incremental licenses. So it's offered separately. You can buy all of them at the same time, but yes, we provide independent licensing.
Okay. I think one that came up before the start of the webinar was how do I start to bring virtualization into my life cycle? There's a couple of phases to that. Virtualization has to start with well-defined interface contracts. From those contracts, it then sort of has to grow as an organic process. So a lot of users and development teams already have mocking frameworks of one kind or another. They may not necessarily be applying them to their APIs yet, but the concept of mocking isn't new. But bringing in virtualization, that's slightly different. There's two ways you can start to do that. You can either have a fully re-implemented code-heavy equivalent of the API, whereby you've taken that WSDL or that REST definition and you've redone it in exactly the same sort of infrastructure tools that your hosting partner or your other team would use, or you've got the option where you can take a bit more of an out-of-the-box solution, much like the one the SmartBear guys do, whereby given a certain amount of API discovery information, it will turn that around and issue that for you, which gives you the option to use the interface that Harsh showed you for creating your API responses for given requests, rather than having to do a fully coded test one. There's pros and cons to either side. Obviously, if you go fully coded, you have the ability to add an awful lot of very clever and very complex logic. If you go the other way, you don't necessarily need automation specialists to the same degree, but at the same time, if you go too much down the coded route, you get to the point where you're effectively rebuilding the API in full, not just a virtual copy of it.
So there are questions around the trial version availability. Yes, we have a trial version. We provide a 14-day free trial. Please go to smartbear.com, Ready API. You will be able to find a download form there, and then you can have the trial for 14 days. So that's available out there.
Okay, one of the questions here is where can we get an API to test, for example? There's a number of places you can do that. There are publicly available APIs on the internet that are just designed for free consumer use. You can also look at generating your own one. If you look for something like a sample WSDL and you want to give yourself an example of an API for virtualization, if you're interested in that, you can find sample WSDLs all over the internet. For instance, I believe W3C has examples of what WSDLs look like when they're written up, so you could use one of those to generate a virtual API for yourself. If you want a publicly hosted API, you'll find that a lot of the big information services providers on the internet just offer one available for free consumption. Others might require some sort of a sign-up or payment, but it depends on what the API is for. So we've got one here. What's the maximum we can do in terms of API testing against a third-party API? When you're testing against a live third-party API or a sandbox third-party API, it's much like testing against any other kind of sandbox or live system. If it's a sandbox, you can be fairly comfortable that you can do most things you would want to do. The problem that you'll find with sandboxes provided by third parties is you don't have the control if you're trying to force specific negative conditions on that environment. If you're going against a live API, I would avoid testing it at all beyond a very simple acceptance check when you commission your system into live to make sure it works. If you're in a virtual API, you can test as much or as little as you want of that third-party system. It's one of the big advantages. You have full control. You can force negative conditions, positive conditions. Depending on the service, you can check your system's ability to make concurrent requests. Virtual APIs give you an awful lot of power, although they are underpinned by you virtualizing to the same specification the live API runs against.
So there are some questions around licensing. If you have a license for SoapUI, yes, if you have a license for SoapUI, you can use it because SoapUI is a cross-platform tool. You can use it against different machines, but it also depends on if you have a fixed or a floating license. You can contact the SmartBear support for any licensing issues that you may have, and we'll be more than happy to help you with them.
Okay, I think that around about wraps up the questions. So thank you very much for your time, taking time to listen to us, guys. Thanks, Harsh, for presenting with me.
Thanks, Dan.
Cool.
All right. Thanks, everybody.
Thank you, everyone. Thank you. Our webinar has now finished. Thank you for attending today and for your questions. Please keep a lookout for our email with the recording of today's webinar and a short survey. We hope to see you at our next webinar, which will be about security on May the 10th, co-presented with Vericode, an application security company. So we hope to see you then. Goodbye and thanks again.